All right, guys, we're on to our last section of chapter 10. Remember, it's only 2 sections long, which makes it great. It's actually the same thing as the last chapter or section, except we're going to be using the equation part of it, not just graphing a stat plot, but more doing with it. So we're going to talk about a regression line. An regression line is given a collection of paired data, sample data, so it has to be sample data. The regression line. Now, a regression line is the same as called the line of best fit or least squares line or least squares regression line. There's so many ways of writing. They all mean the same thing. It's the straight line that best fits the scatter plot of the data. Okay, a regression equation is algebraically describes the regression line. So that's an equation. So our equation is going to be y hat. It's a hat because it's an approximation, is equal to b sub 0 plus b1 times x. Okay, it's an equation. So before, back in the day, you learned about y equals mx plus b. This is if the data is not a sample. This is using data. This is not using data. This is just a straight line. So what does the m stand for? M stood for slope, right? In this case, it's the number attached to your x. So what number is attached to your x? b1. So this is actually going to mean slope. All right, and what does this b stand for? This b stands for your y-intercept. And so our b in this one is actually in the front, and this is going to be your y-intercept. It actually means the same thing, except you're looking at data versus like actual, like population values. Okay, so what is an explanatory variable? A little hint, it's your x value. So that is your independent variable. So write independent variable is the x values. And that means my response variable are my dependent variable. Or my y values. Okay, what are outliers? Well, outliers in a scatter plot are it's like a number that or point that's lying like outside of the regular data. It's like outside of the point. So like, for example, this actually works more in high school than in college, but in high school I ask all my students, hey, what's your age, what's your age, what's your age? If you think about it, everyone in high school is between like 14 and 18 years old, and then I throw my age in. Now if I throw in my age, I'm a lot older than 18, so I become an outlier, and that's what I explained to them. An outlier is a number that's lying away from the other data points. So if I want to know how many like credits they have in high school and their age and see if they're related to each other, if you think about it, in freshman year, you don't have as many credits as you do as a senior, right? And so it should show a positive association or positive line. And then I throw in my data like, okay, I still have the same amount of units as I did when I graduated high school and today, because I'm just asking for units. That becomes an outlier. All right, so here are some notations. I try to make this, I took this from the book and I really liked how organized it was. All right, so it talked about a y-intercept of a regression equation. So I'm gonna write of reg ec for equation. I know, so original, right? Next is going to be slope of reg equation, and then the last one is the equation of a regression equation. Okay, so this is going to stand for regression line. So we're gonna go ahead and draw this out. Again, it's not, I don't know, I have tried to do this quickly. Okay, and then so the top one is going to be for a sample, and this one's going to be of the population. Okay, so a sample, okay, we're using these variables because these are our samples, that's why it's a hat. So we're using y hat equals b sub 0 plus b1x. Okay, which one is my y-intercept? Remember, the y-intercept is by itself, so this is b sub 0. And means my slope is b sub 1. Now, this is where, if you watch the other video, this is where our population comes by. It's actually the same thing, except it's capital. So that's going to be b sub 0, and it's beta. Times beta of 1. And then it's not going to be a hat anymore because it's going to be actual data, is equal to b sub 0 plus beta 1x. Okay. The nice thing about this section is the examples are a little bit different. We're not failing to reject or reject ho. We're going to do a little bit more with that. Okay, so the requirements. Again, the first one is this. It's actually the same as the last section. So what were they? They were SRS of X and Y, and they both have to be quantitative data. Do you guys remember the seconds check? Okay, you have to go ahead and draw a scatter plot and shows approximately a straight line. And what was the third check? No outliers. Again, same as the last section. So this is the same as 10.1. Oh, sorry, moving my chair. Formulas for finding B1 and Y, and so B1 and y-intercept B sub 0 and the regression equation of this. Okay, now again, if you're doing this by hand, you can use these equations. If you're not doing this by hand, which I will show in your calculator, it'll do it for you. All right, so B sub 1 is going to be R times S sub Y over S sub X. And what does each variable stand for? So remember, R is your correlation coefficient. Remember, it's a really tedious way if you can't figure out how to do it by hand. If you do it by hand, it's a really tedious way. You can use your calculator, that's fine. What does S sub Y stand for? That's going to stand for your standard deviation for Y values. And this is for a sample, right? Because if it was, it would be sigma of Y, but this is S sub Y. And S sub X is actually the same thing. It's your standard deviation for X values in a sample. Okay, we're gonna keep going and then I'll keep writing some equations down. So your y-intercept formula is B sub 0, right? Because that's your y-intercept, is equal to y bar times B1 times X bar. So sorry, there should be a minus. Okay, what do each of these variables stand for? Y bar is going to be the mean of, so average or mean of Y values. And X bar is going to be mean of X values. Okay, what do you use like round slope to? I'm gonna say at least 3 decimals. At least 3 decimal places. But like for example, if you have 0.0004, don't write 0, right? 0.0004. Like round it to 4 decimal places. So I'm gonna say then 4. Something like, use your like common sense in terms of how much to round to. All right, let's go on to the next page. So let's go ahead and do an example. Now, I did make a mistake in this and I apologize. So it says using technology to find the regression equation. Use the sample data from example 3 in 10.1 to find the equation of the regression line in which the explanatory X variable is chocolate consumption and the response variable Y is the corresponding Laurel rate. All right, so if you are doing this, the first thing you want to do, whether you're using a graphing calculator or online, before you write the equation, the first thing you have to do is tell me what does your X stand for and what does your Y. Now in this case, it was really easy because it gave it to you, but sometimes you do have to tell me which one is your X and which one is your Y. Okay, so I'm going to do this by hand and I'm going to do this by equation, but first thing I'm going to do is I'm going to say X equals chocolate consumption. And Y equals Nobel laureates. Okay, so let's go ahead and do this by graphing calculator. So if you're doing this by graphing calculator, you're going to go ahead and you're going to go to stat, calculate, and you're going to scroll to number 8, which is ln reg of a plus bx, something like that. So we're going to go ahead and write out what we have. So I'm going to go to stat, calc, number 8. I know there's number 4, but number 8 and 4 are a little different. My B is with my X, while my A is with my X. And I'm using data from L1 and L2. Again, I'm keeping the same data from before, and I'm going to go ahead and hit calculate. All right, now I'm going to go ahead and write this out. Y equals A plus BX. Now in this case, we don't use A plus BX. We actually use Y hat equals B sub 0 plus B1X. Okay, so we're going to write our equation out as Y equals, and instead of A, we're looking at B sub 0. But our A in this problem is negative 3.367, okay, plus, and then our B1 is really our B value, which is going to be, so, or this number and this number are the same, so that's going to be 2.493x. And there you go. This is your equation. You're done. And sorry, I forgot the hat part. There you go. That's it. Now, I'm going to say you can use StatDisk. You can use pretty much anything. StatDisk. I know some of you guys are using Excel. I know some of you guys are using Excel Stats. I know some of you guys are using Minitab. I don't mind as long as you're telling me like what you're plugging in. I really don't mind. Okay, Minitab, StatCrunch. Yes, to find linear regression. Now, that's the one thing. This requires some work. So if you don't, you're just using a regular calculator, you might have to use like Excel and figure out how to do that. Okay. Let's go ahead and calculate this by hand though. So if you don't want to, you can calculate this by hand and we can go from there. So I'm going to go ahead and write the formulas out. So B sub 0 or B sub 1 was R times S sub Y over S sub X. And B sub 0 was Y bar minus B1 times X bar. Now, in order to find B sub 0, I need to find B sub 1. So I'm going to go ahead and go do this first. Now, how do I find out all of these values without actually having to calculate the averages of your Y's and your like standard deviations and stuff? Well, remember we did stat before and we did one bar stat. We're doing the same thing, but this time we're doing a two variable stat because we're looking at two variables. So I did stat, calc, and I'm going to 2, which is a 2 var stat. And I'm going to go ahead and I'm going to write the information down. So x1 and x2 are the same, but I'm going to go ahead and write what information I need. So first of all, I need r, which I don't have just yet. I need s sub y. I need s sub x. I'm just writing out like from here what information do I need. I need a y bar, I need an x bar. Okay, so I'm going to go through this and see what information. So like for example, the top number is my x bar. So I'm going to write 5.804. Then I see s sub x, which I'm going to write as 3.279. I see y bar to be 11.104. Let's keep rolling down. I'm going to see s sub y to be 10.212. And it doesn't tell me what my r value is. So how do I find my r value? I'm just going to go to our linreg, which we did before. I should have written that earlier. So to find my r value, I got r to be 0.801, which again, we kind of cover. I don't know why to put that there. So let's go ahead and plug in some numbers and see what we get as our equation. Okay, so r was 0.801, s sub y, which is 10.212, and s sub x, which is 3.279. I'm going to go ahead and calculate that and see what I get. So I'm going to get 0.801 times 10.212 divided by 3.279. And I got 2.494, which is very close to like if I were to actually calculate it by hand or by calculator. All right, so B sub 0 is y bar, which was 11.104 minus B sub 1, which was 2.494. And x bar was 5.804. So I'm going to do 11.104 minus parentheses 2.494 times 5.804. Ah, 4. I don't know why I screamed. Is negative 3.371. Again, very close to what I got. Okay, so my final equation, remember, is y hat equals b sub 0 plus b sub 1x. I got to be y hat equals, and our b sub 0 was negative 3.371 plus, and then our b sub 1 was 2.494. Now, if this was a negative number, I would actually write minus here because our b sub 1 is the symbol, and then I have x. So this is if I were to do this by hand. Again, very close to what I would actually get. Okay, and then it says use the regression line from example 1. We're going to graph it. Go ahead and graph it. So how do you graph it? Well, on a graphing calculator, this is from section 10.1, is you hit stat, plot. You go to the one that has like looks like this. You turn it on if you want to. And we want to actually graph the equation. Okay, so we're going to go, and then after that, we're going to go ahead and don't turn on Zoom 9 just yet. So the first thing is just make sure it's on. The second step is to make sure that you're going to go to y equals, like literally don't hit second stat plot. You're going to go to y equals and type in equation. Okay, I'm going to write x is next to alpha just to show you guys, and I will show you guys. And then the third step is to hit zoom 9. Okay, so it's kind of cool. It's actually really different from before. So I'm going to go to, instead of hitting so my stat plot's already on, and I have to change this to 1 and 2. Okay, so I did that. The next thing is I'm going to quit and go back to the main screen. I'm going to hit y equals, no second y equals, just y equals. And you're going to get a list of equations. So you just, again, it doesn't matter, like I know students are like, want the color to change. It doesn't matter. Okay, but I'm going to go ahead and I'm going to type in my equation now, which is ever one you came up with. So I'm going to do negative 3.367 plus 2.493x. And I'm going to hit, now once I hit it, I'm going to hit zoom 9. And look, it's going to graph my data and it's going to graph an equation or a line. So when I sketch this, again, if you remember, we already did this sketch before. It's not perfect. But what's really cool is that it graphs an equation or a line through it. Okay? And that's your line of best fit. Okay? So what makes it a good model and what makes it a bad model? A bad model is if the regression line does not appear to be useful for making predictions. Okay? Don't use it if it, like for making predictions. For bad models, the best predicted value of a variable is simply its sample mean. Okay, and what do I mean by that is, like, for example, if my graph, and I know I don't want to screw this up, but I'm going to, if my graph, like my equation went like this, is this equation relevant to this line? And you're like, no, so that's a bad model. And so if it's a bad model, you just want to use the mean of your sample and you're done. You don't even want to do much after that. What's a good model? A good model uses the regression line equation for predictions. Okay, so you're using this to help you predict the future. Or like, okay, if I only gave you values for 10, 20, 30, 40, 50, can you predict 35? And it's like, yeah, if it's a good model, you can. You can use this to like constantly look at data. So it's like asking, like, for example, the number of students and how many hours of sleep they get. I could ask one student and find the number. I could ask 2 students and add them together, and then 4 students, and then 10 students. And like, I can use that to create a model. And I'm like, oh, maybe I can use that to find 8 students. Okay, that's essentially what's happening. Correlation, it says use the regression equation for predictions only if it's a linear correlation. Okay, correlation R indicates that there is a linear correlation between 2 variables. If it's curved, you can't do this trick. What's a scope? A scope is use regression line for predictions only if the data is not too much beyond the scope of the data. You can't predict too far beyond the scope that is available for a sample. That's called extrapolation. Okay, so like for example, I ask 14 to 18-year-olds hours of sleep. Okay, something, or maybe not hours of sleep. I'm gonna ask for I'm going to ask how much money they make. Okay, and I'm going to use this, and usually as you get to 18, some students work. Some students are still not working, but I'm just going to pretend I'm doing this. Then I'm going to go ahead and throw in an age, so I'm going to say 50 years old. And I'm going to say, can I use, like, I make an equation. So pretend my hat was like 3 minus 6x, something. I'm just making this number up. But 50 years old, can I plug in 50 in here? Well, it's like, okay, if I'm only asking 14 and 18-year-olds, can this equation, can I use it for 50-year-olds? Okay, you can't use it because it's beyond the scope. It's like too far from the data to like even figure that out. Okay, and so that's what extrapolation is. Extrapolation is it's too far beyond the information. All right, so it says use the figure to help predict for values of y. So is the regression equation model good? Okay, what makes it good? And it's actually all of these 3 criteria. So it's a yes to all. Okay, it's regression line equation in a scatter plot shows that the line fits the points well. Okay, it's just saying the lines are within all the points. R indicates that there's a relation, shows like R is close to -1 and 1. The prediction is not too much beyond the scope of the variation. So I'm going to say no extrapolation. Okay. So again, I'm going to do 2 examples, and then actually 3 examples. We'll kind of. So it says substitute the given, so if it's a yes to all, you're going to go ahead and substitute the given value x into the regression equation. Y hat equals b sub 0 plus b1x. And you're going to go ahead and you're going to substitute in x and you're good to go. What happens if it's a no? It's a no to one of these. Regardless of the values of x, the best predicted value of y is the best value of y bar, the mean of the y values. So if it's a no, we just need to calculate y bar and you're done. Like there's no plugging in or anything. So let's go ahead and look at this. So it says use chocolate Noble data from previous examples to predict the Noble rate for the country with chocolate consumption of 10 kilograms per capita. So we're going to do this as part A. Part B, it says also predict the IQ score of adults who are exactly 175 centimeters tall. I'm like, okay, well, that doesn't even have to do with the problem. So let's go ahead and do A. So before we do that, I'm going to go ahead and write the equation we got. It doesn't matter which one I use because they're going to be very close. But I'm going to say y hat equals negative 3.367 plus 2.493x. I just went through the previous problem. So what essentially we're going to do is we're going to plug in 10 into our x and solve our problem. So we're going to do y hat equals negative 3.367 plus 2.493 times 10. And I'm going to go ahead and plug this into my equation and see what I get. So remember, minus is not the same as negative. So 3.367 plus 2.493 times 10. And I got 21.563. Okay, and that's my answer. Now, is 10 completely off the charts? Well, if you think about it, my numbers that I gave you were, if you look at my edit, the numbers I gave you, 10 is within these limits. Okay, so if 10's within the x limit, you're fine. If it's not, then that's what extrapolation is. So that's part A. Part B, now think about it, is the IQ score and exactly 175 centimeters tall. Are they related? Does your IQ and your age are related to each other? Well, I didn't give you an equation first of all, so that should be the first hint. The second one, I'm going to say there isn't a correlation between IQ scores and their height of adult males. A linear regression model isn't a good model. I'm gonna just say that, like, by common sense, like, don't write common sense, but I'm just saying it's not a good model. Like, think about it. How tall you are and your mind are not related to each other. Okay, maybe as a kid they are, but as you grow, no, they're not. Another example would be something like, I've given this example before, but like your shoe size and what you got on your last test. Like, are they related to each other? Well, if you don't have data to back it up, these can't be related to each other. Okay. All right. So our last example is going to be from it's like a question from your homework. It's not your homework problem, but it's a question like just like it. So it says, I just picked one of your homework problems that I didn't ask you, and I'm just asking you. It says, find the regression equation letting the first variable be the predictor, or your x, and indicated predicted value followed by a prediction procedure from the chart. Using the listed lemon crash data, find the best predicted crash fatality rate for a year in which there are 500 metric tons. Is this prediction worthwhile? All right, so first of all, let's go ahead and you're going to do this either way with calculator or by hand. And I kind of just did this by hand. You can use the calculator, like you can do your formulas if you want. I just did it by hand. So the first thing I want to do is tell me what my x stand for. Now, it already told me, but this is going to be lemon imports. And I'm going to put this in L5 because I don't want to erase the other data just yet. And I'm going to say my Y is going to be crash fatality rate. And that's going to be in L6. Okay. So I'm going to use technology, and I'm going to go ahead and I'm going to use I'm going to do I don't have to write it all out, but I'm going to go ahead and do ln reg of a plus bx. I'm going to go ahead and write this out. So I'm going to go to stat. Oh, I have to type in the data. I didn't type it in. So 5 and 6. Okay, so 5 was 200, 265, 358, 480, and 530. And then L6 is going to be 15.9. I can be quiet and type at the same time. Okay, so I'm going to do stat. I'm going to do number 8, which again we've done before. And I'm going to go ahead and this is now L5 and L6. Just be careful when you're typing things in. I'm going to hit calculate. And so my equation is y hat equals, my a is 16.146 and my b is negative 0.003x. Is that what I got before? Yeah. Okay. Rounding to 2 or 3 decimal places. I just did it to 2. 3. Okay. And there you go. That's my equation. Okay, so the next thing is we're going to go ahead and figure out for 500 metric tons. So I'm going to go ahead and plug in 500 into this. So 16.416 minus 0.003 times 500. Okay, so I'm going to do 16.416 minus 0.003 times 500. I'm going to get 14.916. Okay, so it's asking, using the listed lemon crash data, find the best predicted crash fatality rate for a year in which 500 metric tons of lemon imports. Is this prediction worthwhile? So this is the last part I have to answer. Now, if you think about it, is 500 within this graph? Yes, 500 happens to be right here. So is this a good prediction? I'm going to say since 500 lemon imports are within the table, I'm going to say the prediction should be okay to use. Okay, notice there's no state plan due to conclude for this last section. It's just straight solving these. Okay, and that's the end of chapter 10.